It's in that 4345 packet. Yeah. Yeah, should be in. Does it say 4345? It's in the middle.
Oh.
All right, good morning. Hopefully you guys all have this morning review worksheet. It's in your 4.3 to 4.5 packets. Okay, solution key is also attached. Okay, let's start with number 1. Okay, so finding average value. Okay, so average value theorem. Basically, average height, formula for average height, 1 over b minus a, integral from a to b of f of x dx. All right, a and b values are provided here, -4 to 4. So ultimately, it's going to be 1/8 definite integral from -4 to 4 of f of x dx. So the definite integral from -4 to 4 is just totaling the area between the graph and the x-axis. So we're only concerned about the regions between -4 and 4. So you can, if you want to kind of lightly shade it in so that you're making sure that you are looking in the correct region. You may see other shapes, but those are not part of our graph, right? Just what's between the graph and the x-axis. So that's, we'll make sure that we are not adding areas that are not part of this diagram. So all these are just made up of triangles and squares. Remember, with definite integral, we have positive and negative values. So anything that's below the x-axis, we have to think of those as accumulations of negative y values. So we're going to get a negative definite integral in return. So this is 1 and 1, 1/2 base times height. We know that this portion is going to be -1/2. Okay. This portion there, that's going to be 1/2. Square, that's area of 1. This is an area of 1/2. This is -1/2, -1/2, 1/2, and 1. All right. We're going to add all these up here. We kept track of all of our negatives. So we know that these two cancel out. (1/2) and -1/2 cancels out, -1/2 and 1 cancels out. So we're just left with 2, right? Definite integral is going to be 2. So we know that the area, or the definite integral, by calculating our regions there, we get 2. So therefore, we have to, don't forget about the 1/8 though, right? We know this area portion or the definite integral portion is 2, but we still have to account for the width. So area divided by width equals the height. Okay, number 2. Now we're finding the average value with a given function. So now we're going to just calculate definite integral using power rule. Again, 1 over b minus a, definite integral from a to b of our function. All right, same formula. Just with this one, we're using a graph. This one, we're given a function, so we got to use the function. Okay, make sure that the bounds are never the first thing to do. You got to take care of your antiderivative before the bounds can do anything with the problem. So we force ourselves to take the indefinite integral. So 4x, this is set up nicely for power rule. So 4x minus x cubed over 3. Evaluate the bounds from 0 to 2. Now we can evaluate the bounds now that we found the antiderivative. Upper bound first. Okay. Minus lower bound. If I plug 0 in for x, I'm going to get 4 times 0 and 0 cubed over 3, which is 0 over 0. So this is kind of like my area portion here. 8 minus 8/3. If I find common denominator, this is really 24 over 3 minus 8 over 3, which is 16 over 3. That's my area, or my indefinite integral. Still don't forget about the 1/2, right? We found all this being 16/3. We still got to involve the 1/2. Let me bleed into part B here. So f of c, my average value is going to be 1/2 times 16/3, which is 16/6, which is 8/3. So that's the answer for part A. Okay, find the C value guaranteed. So what that's saying is, okay, we have the average height, but where is the graph going to actually reach the average height? So we simply set this equal to the function, right? We basically are working backwards. We know what the y value is. We're looking for the x. So just take the original function, insert the 8/3 in for the y value, and then we can solve for x. Okay, square root of 4 is 2. So I reduced it to be 2 over root 3. Now, so we know that these are going to be positive, relatively small numbers there, 2 over root 3 and negative 2 over root 3. But we keep looking at the bounds. The bounds is only showing between 0 and 2. So we know the negative region is not going to make sense. Our only C value, or only location where the graph is going to reach the average value, average height, is at this x value, 2 over root 3. This actually lands inside the interval. Okay, questions so far? Okay, number 3, we start with, we look at the denominator and we realize, okay, this is too messy. I can't split this into individual fractions. I'm not going to be able to just rely on power rule. So this is too complicated for power rule expansion. I have to rely on U-substitution. But to get to U-substitution, let's get the parentheses to show up. Okay, so having those parentheses there is a nice visual reminder where to look for our U value. That's our priority. Get the x squared minus 4x and the dx to be replaced. Find du dx. Derivative is 2x minus 4. If you want to put that over 1, you can cross multiply and solve for dx. We make our substitutions. Now, if you look, it's not a perfect match, right? X minus 2 and 2x minus 4 is not quite perfect. We can't just cancel across addition and subtraction here. But is there anything that I can do with 2x minus 4 to make it look like x minus 2 a little better? You can factor a 2 out, right? So if I factor a 2 out, now I have a perfect match, right? You can cancel across multiplication here. So 2x minus 4 is really 2 times x minus 2. Yeah, that middle setup, it's in the back page there. Okay, I get the x minus 2's to cancel out. Pull the 1/2 out in front. But we're close, but are we set up for power rule just yet? What else needs to happen? Yeah, we can't do power rule if the variable's in the denominator. We don't have a rule for a denominator variable, right? We have to force it up to the top if we want to use power rule. Got to change the sign of the exponent. Now we're good. Okay, now this is power rule. Okay, add 1 to the exponent. Keep the 1/2 outside. 1 negative 1/4 plus 4 over 4. That's 3/4. Flip the fraction. And then multiply and clean up. 4 over 6, that's 2/3. And don't forget, your variable u is a temporary variable, so you gotta bring the original variable back in terms of x. X squared minus 4x. Okay, number 4. Anytime I see an absolute value function, I could split this up into piecewise functions. I think it's easier to just sketch the graph, draw the graph out, and really you're just going to be adding areas of triangles, right? Turn this into a geometric problem. So we can do that because our graph is going to create nice geometric shapes because of the straight diagonal lines. Okay, so first thing we do is we graph that absolute value of x plus 3. Right? So y equals absolute value of x plus 3. That's just going to be a graph, absolute value function with a vertex at -3, 0. And it's just going to open up because it's going to have a positive 1 in front. Okay, there's my vertex. I'm going to extend my graph out and up, going to -5 all the way to 2. Highlight those points. Those will also be the heights of your triangle. So really, we're just finding the areas of these two triangles here. All right, if I plug -5 into my function, -5 plus 3 is -2. Absolute value of -2 is 2. So I know my ordered pair at this point is going to be -5, 2. And that 2 also represents the height of this triangle that we have here. Our base is also 2. So 1/2 base times height. We'll come back to that. Over here, if I plug 2 into the function, 2 plus 3 is 5. Absolute value of 5 is still 5. Order pair is 2, 5. So my height is 5, and my width is 5. So we have all the information that we need to find the areas of these two triangles. 1/2 base times height, 1/2 base times height. Yeah.
If it's absolute values, then why do you put 3 in as a negative?
Oh, -3 is just a location. So basically, whatever causes this to be 0 is going to be what is going to be kind of the starting point of the graph.
Right.
Yeah.
So if it's a positive line, then it's negative on the graph.
Positive. You mean like
positive in the equation, like y equals x plus 3.
Right. Yeah, that's right. Yeah. So your vertex is always going to be the opposite sign of what you see inside the absolute value bar, right? Yeah, your vertex is always the opposite sign of that number. Okay, any other questions? First page. Okay, back page. All right, first things first, we deal with the indefinite interval, right? The bounds plays no role at the beginning, so don't touch the bounds at all. We have to kind of force ourselves to work with this problem here. I'm going to get the parentheses to show up. All right, we look at this problem and we say, okay, can I rely on just expansion power rule? That should always be my first option. This radical is preventing us from being able to distribute through, right? We're breaking rules if we do. We can't resolve this, and because we can't resolve this, we can't distribute the x through. So our first option is out. Second option is U-substitution. So U-substitution, we target the parentheses and the dx. Okay, 16 minus x squared, we find the derivative. 16 goes to 0. Negative x squared becomes negative 2x. Cross multiply, and then solve for dx. X's cancel out. We push the, that's good, right? We want the X to go away if we want to follow through with power rule for U-substitution. There's a leftover coefficient. We got to keep track of this -2. So it comes out as what? -1/2. Okay, now we have a perfect match, right? Now we can do power rule. Add 1 to the exponents. Flip the fraction. Merge the coefficients. And don't forget, bring your X back. U is only a temporary variable for us. Now, do we do plus C here? Because there's what? There's bounds involved, right? So I'm going to take the plus C out. Now we involve the bounds. Okay, sorry, I'm running out of room here. I'm going to put it on a separate sheet. Now you're looking at this, maybe thinking, oh, the bounds are out of place. Do I have to flip them? My suggestion is leave them where they are, okay? Because you're not having to look at a graph, right? If you're having to put something onto a graph, then I would say, okay, adjust the bounds so that you can read from left to right. But here, you're just following procedure. If you flip the bounds, you can, but you got to change the sign. I think it's not worth the trouble. Just go with whatever the bounds is, right? If it's meant to be this way, things will work out, right? Whatever sign we end up at the end is whatever sign we're supposed to get. But you can flip the bounds if you want, but if you do, you got to change the sign of the coefficient in front. Okay, so upper bound first. Now careful, we're going to see this as well later on. Just because you see 0 doesn't mean that it's automatically going to wipe everything out to be 0. Okay, so just keep that in mind, because I think we've seen it enough times where we're going to just begin to assume that 0 is going to wipe everything out. Is 0 going to wipe everything out here in this case? It's not, right? It'll wipe out the X, but the X is not attached to the 16 in the sense that it's not going to wipe out the 16. So just be careful, right? Anytime you see 0, take the time to actually plug in and convince yourself that it actually goes away. Okay, I took care of the upper bound minus parentheses. Then I'll take care of my lower bound. This is root 7 is going to be 7. 16 minus 7 is 9. Okay, this looks like it's not easy to reduce, but you can actually do it without a calculator. Don't look at the 16 to the third power. Look at the square root of 16 first. Right? You can pick and choose which one to do first. Do the one that's going to get you down to a smaller number. What's square root of 16? 4. And then 4 to the third power is a lot easier. Okay, here, same thing. Don't look at the 3, look at the 2. Square root of 9 is 3. Okay, it's a lot easier, right? 4 cubed is 64. 3 cubed is 27. Okay, number 6. Okay, any questions so far? Everybody okay with 5? Yeah.
Last question. It doesn't matter that the bounds are not
Yeah, the bounds don't have to be in order. I would say again, flip the bounds if you're having to do something with a visual graph. If you have to put something onto a graph, then I would say it's easier to have the bounds in place. But if the bounds are out of place, the calculus will handle itself. So whatever the sign is, but you can always if you feel more comfortable flipping this the bounds, you can do that. Just change the sign, make this positive if you want to make it √7 and 0. Is that what you're asking about? Okay. All right. Any other questions? Okay, let's look at number 6. Okay, I'll do a variation of this problem a little bit later. Let's do this one as it stands. First things first, we can't look at this and say, okay, I want to do a rule for cosine, I'll do a rule for sine. Okay, this is one big rule, right? And we have to understand that we can't pick and choose different rules if things are being multiplied. Okay, so we don't have a rule that can handle this. So that's just to say that we have to use U-substitution because we can't pick and choose and say, okay, I have a rule for sine, I got a rule for cosine, and then just move forward. So U-substitution, because of this problem being too complex for any one rule to handle. Let's rewrite the problem and see if we can pick off the U value. Okay, what's our U value? Okay, derivative of cosine is negative sign, right? Negative sign. Okay, put that over 1. Cross multiply. Oops. Yeah, so we're going to substitute. Everything that we need is we can go ahead and insert. U goes in for the parentheses, and dx gets replaced with du over negative sine x. Everything else we're going to recopy back into the problem. See if things will clean up nicely. All right, do the x's go away? Yes, so that's a good sign. There's a leading coefficient. There's a leftover what though? -1. Let's push that -1 outside. All right, so this is nice and clean. Power rule, right? Apply power rule here. Add 1 to the exponent. 1/3 plus 3 over 3 is 4/3. Divided by that fraction. Flip the fraction up to the top. And then bring your x back in. Okay, I'm going to extend this problem a little bit later, but let's come back to it after the rest of the worksheet. Number 7. Give me a second, I need to print something out here. Okay, try number 7. It's the middle packet, yeah. Okay, number 7 is U-substitution with change of variable, right? Okay, give me a moment, guys. I'll be right back.
I think I've been amazing on the papers. I rate it okay. I like Theorem more.
That's what I thought, but I think we're.
I get it, but if I screw up on my own, yeah, it's myself. Yeah, literally. It's like, it's also crossed out. I don't know if it's actually crossed out. Because it's not.
I mean, I'm like, what?
It's not.
It's hard. Oh my God.
What's SFIC?
That would be.
Second. It's second. So it's number 8. Oh. I don't know like what stands for, but I know what it is. Thank you. Yes, ma'am. I always forget like what to subtract from what you add.
Okay, number 7. Okay, we look at this problem, we see that we can't distribute, we can't expand, we have to rely on U-substitution. Okay, target our parentheses and dx. Derivative is just -1, cross multiply. There's an issue, right? We see the x does not go away nicely. So we got to go through a second set of substitution. This is change a variable here. We have to find a way to get that x to be resolved. So we solve for x. X equals 1 minus u. So that is going to go in place of this x here. All right, we can't move forward until all the x's are resolved, and this is our workaround for this x that doesn't go away for us. I'll distribute the negative u to the 1/2 through the parentheses. Careful, if you're multiplying bases, you got to add exponents. There's a hidden exponent of 1. 1/2 plus 1 is 3/2. Now we're ready for power rule, right? All the x's are gone. We took care of them. Now we can do power rule here. Flip the fractions up to the top. And don't forget, I know you made substitution a couple times already, but this is still a temporary variable, right? You want to bring your original variable back into the answer here. So 1 minus x back in. Okay, number 8. 8, if you look, you have the definite integral involving variables, but then you have derivative in front. You know this is second theorem. So second theorem says that we plug the upper bound into the function, multiply by upper bound's derivative, and then subtract out the lower bounds. Okay. Now both the upper bound and lower bound are variables, so we got to repeat the process twice. Once for the upper bound and once for the lower bound. Minus is what separates the two expressions. Okay. Upper bound first, insert the root x in for the t. Times the upper bound's derivative. This is really x to the 1/2, so to go through power rule, bring down the 1/2, and then subtract 1 from the exponent, right? We know that this square root of x is really x to the 1/2. And we just did the power rule for x to the 1/2. Minus, if this was a constant, you could ignore it and just end with that answer. But there's a variable here, so we got to repeat the process. Insert the negative 4x into t. Times the lower bound's derivative. Leave your answer like this. Maybe do some cleanup though if you like. Yeah. I'm sorry? No, we gotta know this. Yeah, this is second theorem. Okay. Okay, so again, the formulas you're responsible for knowing. Power rule for derivatives, trig derivatives, power rule for integrals. First theorem, this is all this saying is just take the antiderivative and then plug in the bounds. Second theorem, trig integrals, and average value theorem. Okay, we need to make sure we know those formulas there. Okay, I'm going to skip number 9. Number 9 is just taking the antiderivative twice. I want to do an even odd function with you, okay? Let me call this number 10 here. Okay, so let's say those are the given properties here, and for part A, given f of x is even Okay, so let's go through our steps here. First thing we do is we identify the shortest or smallest interval bounds between -7 to 3 and 7 to 3. Which one covers a shorter interval? 7 to 3. But we want to start with this. But what's wrong with in terms of what we want to do here? Yeah. Let's flip it to make it easier to graph, right? We always prefer to read from left to right here. So now I will flip the bounds. Anytime I'm trying to put something onto a graph, that's when I prefer to have my bounds in order. So if I flip the bounds, I got to change the sign, right? So really, this is the same thing as this, but it's easier to look at this and graph this, right? So let's do that from 3 to 7. From 3 to 7, we want the graph to show 2, so it's above the x-axis. All right, as soon as we have something down on paper, we got to put it on that other side, right? It's an even function. What can I put on the other side? Also positive 2, right? Even function. We want property that is mirror image. Okay, so now that we have this, let's look at our larger interval, right? So now we can fill this in here. -7 to 3 is equal to 6. I know you're looking at this thing that you want to maybe fill that entire interval there, but this is already finished, right? You just want to fill out the empty spaces. So we know that all these numbers should add up to be a positive 6. There's 2 already showing. What's missing here? 4, and I can split 4 into what? 2 and 2. Does that make sense? Now that you have everything in front of us, now we can add what we need to add. From 0 to 7, it's just equal to 4. Okay, let's say f of x is odd. And now let's find the depth integral from 7. Sorry, for -7 to 0. Okay. We go back to our 2 properties here. We start with a smaller one. We already have this one adjusted. So 3 to 7 equals 2. As soon as you have this down, let's go to the other side. What can we fill out on the other side? Negative. Okay. We want the interval from -7 to 3 to be 6. We want this whole thing to add up to be 6. Don't overlap. This is already finished. We need to figure out what this is. Okay, -2 plus what is equal to 6? 8. And I can split 8 into this is not going to work, right? -7 to 3 equals 8. Sorry, this one. Yeah, I just made up this problem up, so with the odd property, it's not going to span across here. Sorry, let me give a second property that is a better fit here. Sorry, this one is not going to work out because it's an odd function. Let's say an interval from -3 to 0 is 8. So if this is 8, we can say that this side must be -8. So now the interval from -7 to 0, we can add that up, and that will give us 6. Yeah, sorry, I think making the problem up on the fly, had to be more careful there. Okay, I do want to go back to number 6, and I want to try something here. Okay, we worked out this problem without bounds, but let's say there were bounds involved. Okay, let's say we have bounds from -pi/3 to pi/4. All right. So with this, let's say we went through the entire procedure, right? The bounds would not play a role at all. And let's say we worked all the way down to the final answer. Now we can do the bounds, right? If we do the bounds at this point, let's see what happens here. right? Upper bound first. Minus the lower bound. And now we try to recall our unit circle values. Cosine of pi over 4 is √2/2. Cosine of negative pi over 3, the same thing as cosine of 5 pi over 3, which is 1/2. You can leave your answer like this. Okay, I just want to make sure you get any trig expression out of into a fractional value. Okay, I think I've covered all the major topics here: power rule, U-substitution, trig integrals with definite integrals, absolute value function, even odd, second fundamental theorem, average value, given acceleration, find position. That's just the same thing as number 9, where you're just taking the antiderivative twice. Okay. Any questions? Yeah. You can if you want, but I would say just leave it the way it is. I would say it's important extrapolated than whether here, Oh, right. So here, this is the third one.
Yeah, that's a small one. What's that doing?
Wait, when it's like in the parentheses.
Yeah.
Yeah, cosine is cosine, sine is cosine. Yeah. Pencil?
So you know how when you're going along.
You can sharpen it if you want.
This way? Or what is Okay, so like every 30, 45,
Oh, yeah.
right, they get bigger than. But you have to go opposite when it's. So like if it's like -30.
So if you see a problem like this, it's going to be 30.
No, you go like the opposite way. I don't know. It makes.
Yeah, I think with this one, you can choose either one. This is one of those where either one will work. If you let it do the U value, this will clean up, you can let it do the U value, that will clean up. No, you don't. You only do. Well, sometimes it doesn't matter, but sometimes the way you can tell if it matters or not is in the end, if things cancel out to match a rule, then you know that it works. But if things don't cancel out and clean up nicely, then you gotta replug it, like figure out the puzzle.
No, okay, like, it was,
Morning.
Right. So, I mean, this is pi over 2.
Guys, eventually, you're gonna need all your book bags up in the front.
But if it's negative pi over 2,
how far you went this way, you have to go that far. But we're opposite. Yeah, like, you know, you're productive. It's hard. This is hard. I never learned that.
Guys, you can pick up a unit circle sheet. Also, if you want or need a scratch sheet, feel free to grab one on my shelf next to my stapler there.
Oh, you do? It makes sense. It makes sense. That way, it's actually 35 over 2. That's also negative pi over 2. It's like in my head. Over 6 and so.
The second one is what would we do that? Average.
Anybody else need unit circle sheets? Today's 28th.